The square root is simply the opposite of squaring. So if I asked you to do 2 squared, you could tell me that that was 4. So to do the opposite, I would say, what's the square root of 4? We would say 2, because 2 times 2 equals 4. This is handy when you have perfect squares. However, sometimes we don't exactly have perfect squares. So if I were to ask you to say, find the square root of 24, 24 isn't a perfect square. So this is where we need to do a little bit of thinking and recall some of the perfect squares that we know. Before we get started on any example problems, let's talk about some perfect squares that we know. We know that 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. And I could go on and on and on, but I want you to keep those numbers in mind as we're simplifying with our square roots, because we're going to be looking for those numbers that will help us simplify. Square root of 8. If we want to simplify the square root of 8, we know that 8 isn't a perfect square. However, remember those numbers we listed on the previous slide. We listed all of the perfect squares that we knew up through 7, and we know some more too. But do any of those numbers that we listed go into 8? 4 does. So what we can do is we can rewrite this statement as the square root of 4 times 2. Now, one of the things that's handy about square roots is that you can separate square roots. This is the same as saying the square root of 4 times the square root of 2. Well, we already know what the square root of 4 is. We did that on the last example. So we know that the square root of 4 is 2. And we can't take the square root of 2. So our final simplification would be 2 times the square root of 2. Let's look at another one. We're going to start at, let's say we had the square root of 125. Now again, I want you to think about those numbers we talked about. 125 is not a perfect square. However, we do know a perfect square that goes into 125. We know that 125 is 25 times 5. So we can split this up using a property of square roots that says I can say that this is the same as the square root of 25 times the square root of 5. Well, the square root of 25 is 5. And the square root of 5, we can't do that, so we have to leave it under the square root. So we can say that the square root of 125 is equivalent to 5 times the square root of 5. We're just simplifying what we can based on perfect squares that we know. The square root of 216. Is the square root of 216 a perfect square? Not sure. So let's use what we just talked about. Let's think of perfect squares we know that go into 216. I always try to look for the biggest perfect square that goes into 216, but sometimes you just need to start small and work your way up. So 216 can be divisible by 4. So I can rewrite this as the square root of 4 times, let's see, 216 divided by 4 is 54. So we can go a little bit further. We know that the square root of 4 is 2. It escapes the square root and becomes a 2 times the square root of 54. Now here's where we need to look at that 54 again and see, are there any other perfect squares that go into 54? 9 goes into 54. So we can rewrite this as 2 times the square root of 9 times 6. Okay, well, 9 can escape. 9 is 3 squared. So when it gets out of the square root, it becomes a 3. So we already had the 2 times 3 times the square root of 6. Now think about 6 again. Perfect squares that go into 6. None of them. So we can finish this off. We can multiply 2 times 3 and we get 6 times the square root of 6, and we are done. We could have done that a more efficient way as well. We could have started out with 216 and thought, hey, I know that 36, a perfect square, goes into 216. So 216 is the square root of 36 times 216 divided by 36 is 6. So then our 36 could escape. The square root of 36 is 6 times the square root of 6. Now, no matter which way you choose to do it, you end up at the same result. It's just one took a couple more steps than the other. How about the square root of 100? What is the square root of 100? What times what would get us 100? In this case, this is a perfect square. The square root of 100 is 10. Now, to shake things up a little bit, let's say we wanted to find the square root of negative 100. What number times itself again would get you negative 100? It's very tempting to say that it's negative 10. However, think about this. Negative 10 times negative 10 is positive 100 again. So in this case, there's no solution. There's no number, no real number that makes that is the square root of negative 100. In just a little bit, we're going to talk about complex and imaginary numbers, and we're going to find a solution for the square root of negative 100. But for now, there's no real solution for it. The square root of 80. Right off the bat, I can think of a perfect square that goes into 80. I know that 4 goes into 80. So I'm just going to list that off to the side. I know 4 works, but 80 is a pretty big number, so let's think about some other perfect squares. 9 is a perfect square. Does 9 go into 80? No. Okay, what's another perfect square? 16 is a perfect square. Does 16 go into 80? Try it. 16 actually does go into 80. 16 times 5 is 80. So I'm going to use 16 to simplify my problem. The square root of 80 is the square root of 16 times 5. Well, I know what the square root of 16 is. It's 4. So when that gets pulled out of the square root, I have the 4 times what's left over, which is the 5. So 4 times the square root of 5. There are no other perfect squares that go into 5, so we are done. 4 times the square root of 5 is the simplification of the square root of 80. Now, let's say I didn't want to go all the way up to 16 when I was thinking of my numbers that worked, or I forgot that 16 went into 80. I could do this the other way too. I knew automatically that 4 went into 80. So I could say, I'm skipping, we're done with that one, I'm moving on to a different way to solve it. We could say that this is the square root of 4 times 20. Okay? Well, if we simplify that, we're going to get 2 times the square root of 20. But we need to look at that 20 again. Do any perfect squares go into 20? Yeah, 4 goes into 20. So this is 2 times the square root of 4 times 5. When the 4 comes out, we're going to get 2 times the square root of 5, which is 4 times the square root of 5. We got the same answer. We just took a couple extra steps to do it. This is why knowing your squares, perfect squares, is kind of important. I know that a lot of you guys like to use calculators. You don't want to memorize anything, but you're saving yourselves a lot of work if you know some basic multiplication facts. We're just going to look at another couple examples to give you guys a taste of what this looks like. Again, it's just going to be a matter of remembering those perfect squares and trying to seek them out. So let's say we had the square root of 45. Perfect squares are going to 45. 9. 9 goes into 45. 45 is the square root of 9 times 5. Well, the square root of 9 is 3, so that escapes the square root. What's left over is the 5. 3 times the square root of 5 is our final answer. Let's look at another one. Let's do the square root of 75. Start thinking of those perfect squares that go into 75. Does 4 go in? No. 16? No. 9, like the last one? No. 25 does. square root of 75 is the square root of 25 times 3. Well, we all know that 5 times 5 is 25, so when 25 escapes the square root, it becomes a 5, and we're left with the square root of 3. So the square root of 75 can be simplified as 5 times the square root of 3. What if we have another number out front? In this case, that's just a number that's getting multiplied by what's in the square root. So negative 8 times the square root of 24, that's just going to give me a number at the end. So let's just focus on the square root, and let's try to think of perfect squares that go into 24. 4 goes into 24. So it's negative 8 times the square root of 4 times 6. Now we can simplify a little bit further, and we get negative 8 times the square root of 4 is 2 times the square root of 6. Are there any other perfect squares that go into 6? Nope. So we're left with negative 8 times 2, which is negative 16, times the square root of 6. That extra number didn't change anything about our steps. We just had to multiply an extra number at the very end. We were still thinking about the same thing, still looking for perfect squares. Like even if we had 5 times the square root of 72. Kind of ignore that 5 for now, and let's focus on 72. Perfect squares that go into 72. 4, 9, 16, 36, 25, 36. 36 goes into 72. This is the same as saying 5 times the square root of 36 times 2. See why knowing those multiplication facts is handy? So we could simplify this a little bit. The square root of 36 is 6 because 6 times 6 is 36. What's left over is the 2. Now we can finish off this problem by doing 5 times 6, and we get 30 times the square root of 2. So the simplification of 5 times the square root of 72 is 30 times the square root of 2. Simplifying square roots just means trying to get those perfect squares out of the square root symbol. We want to get them out in front. Sometimes we're lucky and we have something like the square root of 100, which we can simplify very easily. Other times it's going to take a few more steps. This is why it's important for us to be familiar with those perfect squares. I'm going to remind you of some of them right away. 4, perfect square, 9, 16, 25. Let's see what's next. 6 times 6, 36. 7 times 7, 49. 8 times 8, 64. 9 times 9, 81. 10 times 10, 100. Now, it's good to know more than this too, but as long as you have these first ones down, you'll at least have a leg up on most of our simplifying square roots. And again, it's important to be able to do this because we're going to be working with complex numbers pretty soon, which involve negatives as well. So the better we are at simplifying square roots, the easier solving or simplifying complex numbers will become.